see here, because the way it's also written is you just do an alternate version of 50. The kind of the way it's written is to simplify tangent of theta times cosine of theta. So tangent is sine theta over cosine theta. And then cosine theta is just itself over 1. And you can see that these cancel.
Yeah.
So you're just left with sine theta. That's kind of the other direction I'm kind of feeling like this problem could have gone, because it works real well with the next one. Like 51 is kind of a simplify, for sure 52 is. I don't know. You have to kind of tell me what you think. Or
yeah, that looks good.
okay. And actually, if we look at 53 through 58, you're kind of going into that direction there.
Right.
Okay, so let's go back and summarize what not to do first. You're not doing this. You do need to know this.
Yeah.
So this is where you may have to ask if we're going to get on the test, or if we're going to have to memorize it, or both, or neither. You know, you want to know what the requirement is of you. So this stuff is also, we don't want to do it this way.
Right.
Okay, so let's go to, I sent that as a link in case you need it. Let's look at the next one here, 51. Cosine theta times cosecant theta. So there's these strategies when you're working on these types of problems. And the very first strategy is to put everything in terms of sine and cosine. Okay, so cosine is already in terms of cosine, but can cosecant be written in terms of cosine? And that's where you've got to go to that reference sheet I sent you, the reciprocal identities, and look for cosecant.
Right.
Okay, so I'll help here for a while. I mean, you know, showing you something 4 pages long and then expect you to go find it, but it's on page 2 there at the top left. So you're supposed to know in this problem that cosecant is really 1 over sine.
Yeah.
When I say it that way, I hope you take it as like that's the intention of the problem, that you are going to know this information in the future, so that when you see a problem like this, you know the direction to go. Now you're left with something that maybe doesn't look any better, right? Cosine, okay, 1 over sine, not great, but you multiply the top, cosine theta over sine theta, and then you're supposed to say, oh, I've seen that before.
Yeah.
And that's where this comes in. You're like, oh, that's really cotangent. So let me try to give you another way to look at this that might be helpful here. If you were to graph the first one, and to graph the last one, they would be exactly the same.
Right.
They're equivalent expressions. So you might ask, well, why would they do this? Or what's the point? I don't know. These are just trigonometry problems. I had a student probably a month ago, he had a test on basically everything you've got in your homework tonight. And these things just get monstrous. It was like a take-home test where he had to find the 3 that they were going to give him in person. And anyway, a lot of math. But any questions on that, or anything you feel like is unclear that I should clarify before moving on to the next one?
No, I think I got them.
So the next one here is sine theta times secant theta over tangent theta. Again, that first strategy is to put everything in terms of sine or cosine. So sine is already good. Could you look on that reciprocal identities and tell me what secant can be rewritten as?
Is it 1 over cosine?
Yes. Okay, now this is where you gotta be careful here, because this strategy doesn't it's not like it always works, always do this and you're set. You almost need to, it's not really a strategy, but it's like looking ahead. So you have to look at it and say, well, what does sine over cosine become? And that's the reciprocal identities. Or I'm sorry, the tangent and the cotangent identities.
Right.
What is sine over cosine? What's another way to write it?
Tangent.
Tangent. So the numerator becomes tangent and the denominator stays tangent, which means that it becomes tangent over tangent, which is equal to 1.
Okay. Yeah.
Thoughts, questions on that? I think.
No, that one makes sense.
Okay, because I think they're about to get more difficult. Just
Okay.
take a look here. No, I take that back. I mean, they're just more of the same. So 53. Why don't you try 53 on your own? Just see how far you can get on it.
So would you do cotangent times 1 over cosecant?
You really want to turn everything into sine and cosine. So if it's already sine, you keep it as is. The cotangent should be manipulated
Okay.
because it's not sine or cosine.
So would that be 1 over tangent?
It is, but sometimes like it takes you almost like that's not very helpful because again, you want it in terms of sine and cosine. So like you're kind of, you're getting closer. It is the tangent and cotangent identities there.
Oh, is it cosine over sine?
Yes, yes, yes.
And then times 1 over cosecant.
You want to
Or-
get everything. Yeah, you want to, if it's already in sine, you just keep it. Sine or cosine, you keep it.
So then just times sine.
Yes. Yes. And then you say, okay, are there any cancellations here?
Sine.
Yes.
So then it's just cosine.
Just cosine. Yeah, you did well. I mean, that's kind of a horrible one.
Yeah.
They get worse as you go here. All right. So I want you to use the same approach here for this one, but I'm going to be more helpful here. So for secant, you're going to turn secant into something in terms of sine and cosine, and then same thing for cotangent. I need to step over just 30 seconds to turn something off, but I'll be right back. Why don't you just see how far you get on this one? It does work out nicely.
Yeah.
All right, I am back. The secant here, you want to write that as 1 over cosine theta. Cotangent is cosine theta over sine theta. And then just keep the sine theta as is. So if it's sine, you keep it as sine. Everything else you turn into sine and cosine. What, any questions on that, or do you kind of see how we're just breaking each one apart and then simplifying?
So, how did you get 1 over cosine?
That's a reciprocal identity. So everything that we're doing here, let me snip this in again. It's like,
Oh,
and it's like, well, which one do I use? Like, it's like, that's the challenge here. Is like, it's like a puzzle in some ways, which maybe you don't like puzzles, maybe you do. Everything we're doing right now is coming from this block, these two.
yeah. So then this would just equal 1.
Yeah.
Okay.
All right. So that, they occasionally, these are designed to kind of work out nice. This is another one. Okay. So 55 here. 55 is kind of the last of the quote, air quotes, easy ones. Then we get some other things potentially in play here. So this one is cosine theta times cosecant theta. So again, if it's not sine or cosine, which that's what this one is here, cosecant, you have to convert that using one of these identities over here.
Yeah, so you do cosine times 1 over sine.
Good. Okay. And then this time you multiply the top, keep the bottom, and you're supposed to say, oh, I've seen that before. That, that's blah. You have to now know that this is
Cotangent.
yes, exactly.
Okay, that makes sense.
All right. Fantastic. So, and you're sure we're doing 59 through 67? These just increase the difficulty quite a bit.
Yeah,
that's fine
let
with
me
me.
look at it again. Oh yeah, well we got a we got a kind of like cheat sheet that we get to use on the test, and he kind of like gave us an example of one of these.
Yeah. So here's 3 more things to remember. I gave you 9 things. Now you got 3 more to remember. These are all in play for this one. And so if you have that cheat sheet, have it out. What happens is over time you just know these because you've seen them before. Now I saw this in another student. I guess I'll try it with you to see if you like it. The first one is actually 3 things in one. Okay. You can, for example, solve this for sine squared. Sine squared theta ends up being 1 minus cosine squared theta. So that, without showing it, it's moving the cosine squared theta over to the other side. Is that okay or
Yeah.
not? Okay. You can also solve it for cosine squared theta. Cosine squared theta is 1 minus sine squared theta.
Right.
Now, small thing here, this is just notation when you put the number, the exponent after the sine, cosine, tangent. That's just notation. Like it like when someone writes sine squared theta, what they really mean is the sine of theta, then square it. It's really sine theta times sine theta. But here is what's wrong. You cannot write sine theta squared. This is wrong.
Why?
Because it implies that you're squaring the theta before
Yeah.
you take the sine of it. So that's why it's recommended strongly to put it there. It really matters in future courses. So I think you're going to be fine with it. You have to get used to it, but it's an awkwardness notationally. So then the third one is just as is, sine squared theta equals, I'm sorry, sine squared theta plus cosine squared theta equals 1. So each of these has like 3 different ways that it could appear. I don't really want to go into all of them right now. I'd like to work on some problems, but just keep that in mind. It's really like 9, even though it's 3, but eventually you just get used to them. You're like, okay, I got it. I work on these. So problem would help. We'll look at 59, 59. No, 56.
56, I think, yeah.
Way off here. Cotangent squared theta times 1 plus tangent squared theta. So whenever you see something squared, your identifier, your antennas have to say, oh, it's probably a Pythagorean identity whenever you see something squared. And that is the case here. Now you might say, well, is it this one squared or is it this one squared? That's where you got to know your Pythagorean identities really, really well so you can quickly identify them. So it is this middle one. Snip this one in. It is that tangent squared theta plus 1, which is the same as 1 plus tangent squared theta. Secant squared theta here on the right is going to replace the 1 plus tangent squared.
Mm-hmm.
Now, you're probably not used to substituting in for more than one thing, but that is what is done in these problems. Like you don't want to solve this. You don't want to solve this one for tangent squared theta and then put it back in. You want to get comfortable with the idea that you can substitute in for 1 plus a tangent squared.
Right.
So this becomes secant squared theta times cotangent squared theta. Here's another thing that students really don't like is they don't know when they're done. They say, well, how do I know when I'm done? How do I know if this is done or if I have to keep going? It's a fair question. You go until you can't simplify any further, but how do you know that? And unfortunately, the answer is lots and lots of practice. You get to the point where you realize, okay, there's no way to rewrite this in such a way that it can reduce, but you keep going, you keep trying. So cotangent, for example, is cosine squared theta over sine squared theta. And secant squared theta is 1 over cosine squared theta. So all of those reciprocal identities that I showed you earlier, they can all be written where you have squares. So if it's cosecant squared, it's over sine squared. Secant squared, cosine squared, and so on. It could be cubed if you wanted. They all work.
Yeah.
So more to remember.
Right.
Okay. But the nice thing here is you might see some cancellations. You might say, oh, there's a cosine squared on the bottom. There's a cosine squared on the top. So this becomes 1 over sine squared theta.
And that's just the answer.
Almost. You have to recognize that this is a reciprocal identity. It can be written as cosine squared theta.
Yeah.
Now it's done.
Yeah.
Okay. And all right, 57. So this is sine squared theta times cosecant squared theta minus 1. So whenever you see a squared, you first should think, I wonder if it's a Pythagorean identity. This one is. But it's not as explicit as the last one.
Yeah.
The last one, it was just, all right, it's right there. You could, for example, substitute in for cosecant squared theta, this 1 plus cotangent squared theta. That would be totally fine. Like you can instead of this write 1 plus cotangent squared theta minus 1, which becomes cotangent squared theta.
Right.
So that's kind of way one to think about. The other way to think about it is, well, if you subtract 1 from both sides, cotangent squared theta is cosecant squared theta minus 1. That's what you have. And I'm sorry, that's what's there. So instead of cosecant squared theta minus 1, you're going to substitute in cotangent squared theta, which is why you get this down here. You, the math student, have to figure out which way do you want to do it? Which way
Yeah.
makes more sense to you?
Yeah.
Now, are we done?
No.
Right. There's more to do because cotangent can always be written as sine and cosine. So that first strategy I said where you put everything back into sine and cosine. So this is sine squared theta. Oh, I'm sorry, cosine squared theta. Boy, that's bad. Over sine squared theta times sine squared theta over 1. Those cancel. And you get cosine squared theta.
Yeah.
So the analogy I want to make here, no, maybe that's not the right word, but we were doing some problems a while back where it was like x squared minus 5x minus 6 over x squared minus 36 divided by x squared minus 5x plus 4, something ridiculous like this.
Right.
Like this. And it sometimes worked out to like just 1 or it'd become like x minus 6. And that's kind of what we're doing here. You're just rewriting stuff until it cancels. You ever played there's numerous games, but the original was like Tetris, now it's like Candy Crush, and I don't even know idea what these games where you basically move things around and they cancel, cross out.
Yeah.
That's what we're doing right now. We're just rearranging stuff until we get something that works. It's just math.
Mm-hmm.
Okay, I'll just keep going here unless I hear otherwise. 58. 58 is secant theta minus 1, secant theta plus 1. Sometimes you have to do some other stuff besides just, like I said, like if you go by all the stuff I said today, it's like, hey, I'm going to change secant theta into 1 over cosine, secant theta into 1 over cosine. While that's true, sometimes you want to do some other things. Some other things that you might have at your disposal are FOIL, factoring. We'll get to some other, I guess, exponent rules. We'll see. There's a lot of other things that are in play here. So this one is actually better to factor first. Or I'm sorry, FOIL first. Boy, that's bad. I apologize.
That's okay.
Yeah. So this is secant squared theta. That's the first times secant theta. The inner is minus secant theta minus 1. Do you see anything that cancels?
The secant minus secant.
That's right. So this becomes just secant squared theta minus 1. And now you're supposed to say, oh, it's a squared. Maybe there's a Pythagorean identity. So you go to the one that's got what you have in it. The only one that has a secant in it is the middle one. Secant squared theta is tangent squared theta plus 1.
Right.
So you're going to there's two choices here. You're either going to say, I'm going to substitute for secant squared. So instead of secant squared, you're going to write tangent squared theta plus 1 minus the 1. Or you're going to move the 1 over and it just becomes tangent squared theta, which is what you see on the left here. It's just tangent squared theta. Thoughts on that? Questions?
No, I'm just writing down.
This is a lot. This is so much to put on a Algebra 2 student.
Yeah. Is this a lot like pre-calc?
Yes. Yes, you're doing pre-calc stuff right now.
All right.
Okay. So what I'd like you to do here, just because I need to grab something real quick from the kitchen again, try foiling this, and I'll be right back to check on your work.
Okay.
All right. Any questions about foiling this?
The only thing is like, how do you foil? How do you like? What do you write whenever it's comes to the part where you have to do negative cosine times secant?
Yeah, you just write them together,
Okay.
and you hope that this works out really well. You're like, all right, well, I'm just going to do it, and maybe something good will happen. I don't know if you like doing puzzles, but this is a lot like a puzzle. You work on a little bit of it, you work on another little bit of it, and kind of all works out.
Right.
So what we have here now after you foil is more like one of the first few problems we were doing, where you want to turn everything into sine and cosine. Okay. So for example, you might write 1 over cosine theta for secant. And then for this cosine theta, secant theta is cosine theta times 1 over cosine theta. And you're supposed to say, oh, I've seen that before. Like cosine theta on top and bottom is just 1. Okay, just the 1. And then there's a 1 on the left that it can combine with 1 minus 1, and they all go away.
Yeah.
So there's a lot of just going and say, okay, well, if I do this, what will happen? And maybe it gets better. All right. So here you're left with this. You might think, okay, like I'm done. What else could I do from here? Right.
Yeah.
But there is a bit more to do. And like the analogy would be sometimes there's like numerical problems like, what would you do if it's 1 over x minus x? You would make a common denominator. So your common denominator is cosine theta, which means you have to multiply the top and the bottom by cosine theta. So this becomes 1 over cosine theta minus cosine squared theta over cosine theta. And now that the bottoms are the same, you can combine the tops and keep the bottom.
Right.
And now you're supposed to say, oh, aha, I've got a squared. It must be a Pythagorean identity. So you go to your Pythagorean identities and you look for the one that has a cosine squared in it.
Yeah.
You say, oh, well, cosine squared theta, I can either solve for it or I can put, I can move the cosine squared theta over to the left. Like this is where I'm sort of asking you, like, how do you see it? Do you see this as, hey, let's solve this Pythagorean identity for cosine squared theta, or do you want to solve it for 1 minus cosine squared theta?
I'd probably say the Pythagorean theorem, or the Pythagorean identity one.
Right, but I'm asking, like, do you want us to subtract? I'm sorry. Do you want us to subtract cosine squared theta? Like just looking at the left. I'm sorry, the right. Gosh, I'm so really. I'm tired, frankly.
Me too.
But we're gonna get through this one way or another.
Yeah.
What I'm asking is, do you see it as, okay, I'm going to get the right side as 1 minus cosine squared theta so that I can put sine squared theta in for this?
Yes.
Okay, so now the top becomes sine squared theta over cosine theta. And it's a good it's like sometimes you're like, this doesn't look any better than the previous line, but it kind of is in some ways, because there's no more 1 minus, there's just one term in the top. You're supposed to now be like, okay, like what else can I do? And this, again, kind of non-obvious until you've done a few of these. The numerator becomes sine theta times sine theta. And then you put the cosine theta over just one of them, because it's not like they're adding, so you don't do both. And then you say, oh, okay, I've seen that before. Sine over cosine is really tangent.
Yeah.
And then you have it.
Okay.
All right, so the every problem is a slightly different version. Like, there's not like, oh, here, let me show you one and then you can do one. It's not like that at all. There's some that are kind of similar, like we saw in the beginning, but as they get more complicated, you then have to kind of look for things to do. Now, it kind of interestingly, the next one is not necessarily as difficult as the previous ones. Yeah, they just, maybe they kind of reset it when they did this. But what you kind of want to see this as, sometimes, again, a good to kind of come off the side, like, all right, what is this? It's like y plus x over x. So if you're wondering how I'm doing that, I'm just picking the one that's the same to make that x and giving the other one a letter. And you might say, oh yeah, I can divide both of these by x, and the one on the right becomes 1. Okay, we're going to do that here. So I'm going to divide each of these by sine theta. So on the left, cosine theta over sine theta becomes cotangent theta. Sine theta over sine theta is 1.
Okay.
So I wish I could be like, okay, here's another problem like that. I mean, we kind of can. They're all kind of a little different. They're not a. Okay. This will just go on in order.
Yeah.
Okay, so we've talked about putting everything in terms of sine and cosine. We've talked about the Pythagorean identities. We've talked about some algebra. We did some FOIL in the last one, dividing, common denominator. Kind of all this stuff is in play. If I don't tell you what to do, it's like one of those things, right? I'm not sure you could ever get to the solution. Like, you'd be like, because you can go off in the wrong direction. It's like going in the woods and you get lost before you find your way. But what I see in the numerator, and this is, by doing more problems, you start to notice this, is the top ends up being difference of squares.
Right.
Okay, that's a squared minus b squared becomes a minus b, a plus b. And that's where you have to be like, oh, is that what I'm supposed to do?
Yeah.
And it's like, I'm sitting here like, well, Not sure, because there's a couple other ways that we could go here. The other direction we could go is take each of these and divide it by this. Now, the advantage of that is you will see some cancellations. Like what I mean by that is cosine squared theta over sine theta cosine theta minus sine squared theta over sine theta cosine theta. There's no right, wrong direction to go here.
Right.
Okay, and if you make it difference of squares, you can still get to the right answer, but it's like, well, which way is better? So this is, and this probably won't sound very appealing, but this is like, if you were like, if you love math and this is like what you live for, you would actually try it both ways and see like which way was better and why. As a student though, you're probably like, I want to get there as fast as I can. And that's the challenge. Like, I can't tell you until I've worked through it to know like, yeah, this way is better, or the difference of squares is better. It's a little bit of a guessing game.
Right.
So I'm going to suggest we not do difference of squares for the time being and just do this kind of break apart.
Yeah.
So this ends up being this cosine theta canceled that one. This sine theta cancels that one. So you've got cosine theta over sine theta minus sine theta over cosine theta. Which becomes cotangent theta minus tangent of theta. And you might think, well, how do I know I'm done here? And it's a fair question. If we take this line right here, we say, okay, let's go off in another direction. Like, let's make a common denominator. Well, if we make a common denominator, we get back to where we started. So that's not the right answer. Like, you never want to go back in that direction. There's no way to combine cotangent and tangent. They're opposite, they're different reciprocals. There's nothing you can do there. The only other question is like, would difference of squares been better? Would writing it as cosine theta minus sine theta times cosine theta plus sine theta be better than sine theta cosine theta? I'm not sure. Oops. But it doesn't look like it. Okay. I know, I'm sorry I'm giving you so much information, but really, like, this is how you have to think through these more challenging problems. The other thing to do here is to look at this and say, well, can I use one of the Pythagorean identities because it's a squared and a squared? Is there a way to like turn everything into sine theta at the top? And that's the challenge.
Yeah.
Or the puzzle of these. All right. We'll move on to 62. All right, so this time, unlike 61 and 60, 61 and 60 added like a single term in the bottom. This now has two terms in the bottom. So you generally don't divide when you have two terms in the bottom. You're looking for something else.
Yeah.
This one we're kind of in the vicinity of Pythagorean identities, because the ones, whenever you see 1 plus or 1 minus, that's also a pretty good indicator that it's a Pythagorean identity. So do you see anything here that might be useful?
Is it the 1 plus cotangent squared?
Okay, so if we do that, that's, oops, wrong color. All right, over cosecant squared theta, that's great. Couple of choices from here. You can divide each of them by this, or you can work on 1 minus sine squared theta as a whole, because you have another identity up here. What do you think? Do you want us to divide? Do you want us to try to use one of these identities? What do you see?
Divide.
Okay. And I actually should have looked back sooner. It does say that there's no quotients in the final expressions. That's a good indicator. No divisions. Let me just quickly look. And that doesn't have. Yeah, okay. Yeah, basically no quotients is a good thing. So this becomes 1 over cosecant squared theta minus sine squared theta over cosecant squared theta. What is 1 over cosecant squared theta?
That is sine.
Sine squared theta. Now this one on the right, a little bit more cumbersome. This is 1 over cosecant squared theta. I'm sorry, 1 over sine squared theta in the bottom.
Wait.
So the cosecant, yeah, the cosecant squared theta is all of this down here.
Oh yeah, okay.
Okay, and this looks bad. You know, you don't want to have fractions at the bottom. So you multiply top and bottom by the reciprocal.
Right.
Okay, so in the numerator, you end up getting sine to the 4th theta. Sine squared theta minus sine to the 4th theta. This kind of appears done, but there's just a little bit more to do because it's generally bad to leave these higher order exponents. You can factor. So you pull out a sine squared theta from each. And then you're maybe like, oh, I've seen that before. 1 minus sine squared theta. 1 minus sine squared theta. What could that be? And you're like, oh, it's a Pythagorean identity. You say, okay. It comes from this first grouping here. So notice if you subtract sine squared theta from both sides, cosine squared theta equals 1 minus sine squared theta. Everything in parentheses become cosine squared theta. And that will probably do it for that one. You're like,
Yeah.
okay, finally got it. All right, are these all due tomorrow?
They're gonna be due on Tuesday.
Okay, I'll give you some guidance on the rest. So 60, 63, you're going to want to make a common denominator. 64, you're going to want to FOIL. 65, distribute. Then the sine cosine thing. Same with 64, you're going to use sine and cosine. 66, you're going to use identities. And then divide each of them. And then 67 is kind of done. It's identities in the numerator. I know that's a little vague. I do have probably half a dozen videos on this stuff on my YouTube channel. If you search for something with the right word, search. His name is Jaden R. He's got a bunch of lessons on this, but you could also schedule something for tomorrow if you'd like, but that is going to do it for us for today, unfortunately. Wish we could save some time for one of our other lessons because you definitely need a little bit more for this one.